Hello, everybody. I am Johannes Wolf. I'm a cancer researcher, and I have sat with many of my PhD students at the computer to show where to click to come to Kaplan-Meier curves. This was all before COVID taught us how to do remote lectures, so here we record it as a slide presentation. I will put the links of the previous videos in the descriptions. Those were basics, how to read the curves and the PFS paradox. Today, we will make Kaplan-Meier curves. The flow of this video will start with a short example, where to click to make your first curve. But after that, we go a little bit deeper into the details of the dirty reality of real medical data, show you how to prepare them in Excel so that you can make those curves. I'll give you a short overview of the most commonly used software, show you how to import it in one of those softwares, SPSS, how to make the curve there in SPSS again, and how to save it as code. When you want to make Kaplan-Meier curves, regardless which software you use, you will need 2 columns of data at least. One of which is numeric and describes the observation time of the patients. The other one is binary and describes if in the end of that observation there was an event or no event. If it's no event, we call that censored, the column with the time, and what is the column with the status, the event. It will list all your variables here. In this example, we only have 2. You pull time over here, event to status, and then SPSS will ask you to define the event. It doesn't know yet that Y means the event. You click on it, you give the answer, you click continue. Now you could click OK and you would get some calculations, but it wouldn't be the graph that we want. For that, we still need to click on options. And there is a standard choice of survival tables and mean and median survival. Those are very important data. What we want today is a survival plot. So you unclick the others, you click on survival, and then you click continue. You're back at that screen, and now you click OK. It opens a new window. It's called the output window. You pull that to the middle of your screen, and you see your first Kaplan-Meier curve. You can click on that, copy it, paste it into Word or PowerPoint, and describe your work. You can also work within SPSS to make it prettier. But before we go there, let me show you the reality. In real world, medical data are always dirty. We need to learn to cope with that and clean it up. If there is anybody who knows how to clean the data and make them not dirty such that you can draw a clean Kaplan-Meier curve, I can guarantee that person can also do a Kaplan-Meier curve. Personal identifiers are a danger to your work because if you have them on your computer, then they can end your career very fast. There is a list of personal identifiers, and that list is growing. Make sure none of those things are in the data. Then, once the data are clean, you check them. Make sure they make sense. That is easiest done just one line at a time. So what do we have here? We have an identifier. Is that a personal identifier? No, it is not. It is just the number of the line, and it is kind of important when you want to talk to other people. If you sort the data in a different way, these lines appear in a different place, and you better have an identifier so that you can talk to somebody else and ask questions if necessary, or give answers if they ask you. The first column here is named C1D1. That is pharmaceutical company code for cycle 1, day 1, the beginning of the treatment. Commonly, the starting point of an overall survival curve. Sometimes it's not that. Sometimes it is the day of randomization. Make sure you got the right starting date. Then there are a couple of other days. This patient here appeared to have the last data entry on January 25 after starting the drug only on January 1st of the same year. And the explanation why that happened is the date of death. The patient passed away on that day. That explains it. And it also says on 115 there was tumor progression. Well, that is an extremely unfortunate disease course, but the story makes sense. Other lines here are more complex. Look at this one. 4/1/2001 was cycle 1, day 1, and that is also the last day of entry. That's not good. Assuming we are on April 2nd, 2002, there could be a lot more information here. We don't even know if this patient has left the study or is still on treatment. That would trigger a query in my review. Once you're satisfied that your data allow you to do some more analyses, you keep working to get the columns that you need. If you try to get the data up to the level that they can be sent to the FDA, you will never get exploratory analyses done. So at one point, you just need to accept that it's not perfect, finish the analysis, and be clear that you have to repeat this when the data become more clean. Now, we have the data, they are clean enough. We have asked that question, we didn't get an answer. Now we want to move forward and just see what's in there. But we don't have the two columns. Let's start with the first one, OS event. Remember, this was just a Y for yes and an N for no if there was or was not an event. You can hand fill this in, but filling it in from hand has its own source of errors. Typically, we program things like that. And you can do that very easy in Excel. When you type into the first cell or up here in the entry field of Excel, an equal sign, then Excel will know that it doesn't have to just write down what comes there as a text field, but instead calculate what comes after the equal sign and then write the result of the calculation in there. That could be simply adding up two numbers, or it could be more complex like it is here. Maybe the most important order of all kind of programming, at least it was the first one I learned, is the if, then, else order. In most programming languages, these three words are actually there. And after the word if comes the condition. That is an equation by itself, but it doesn't end with a number. It ends with a true or false. Then there is the word then. And after the word then comes what the computer is to do if the first equation ends up to be true. Then comes the word else. And after that, what the computer is supposed to do if the first equation turns out to be false. In Excel, these two words are substituted with commas. After the word if, there are parentheses. Everything inside the parentheses belongs to the if. So the first one is the condition. This is what is to be filled, what is to be calculated and comes out as true or false. We tell the Excel to look at F2. Here is the field. Excel even highlights it while you're typing up here. And it looks if F2 is greater than 0. That is another way of saying, is it filled in? If it's not filled in, this will be false. And if it is filled in, this will be true. And if it is true, then Excel will go after the comma to the first space and type in a Y. And if this is false, then Excel will go after the second comma and will type in an N for no. When you hit enter, Excel will calculate it, and then you don't see the text of the equation in here anymore. You see the result. And then when the cell is clicked, you also see that little square. You grab that square with the left mouse, click and pull it down. Check it to make sure your equation is right. So here we have a date of death. The event was there. It's supposed to be yes. We do not have a date of death. This patient was more lucky, had a progression, but no death. This is a no for the OS event curve. So this is correct. It worked. You can do that for all the other fields as well as they are necessary. We went over this equation. The OS date is very similar, except that here, if it is a no, there is another if order. So let's go over that for an example. Equal sign tells computer, please calculate, don't type it in. If is in order and everything be between the parentheses, and those are the outside parentheses, belongs to this if. The computer will go in, will check this condition, F3 larger than 0, yes or no, true or false. If it is true, then it will not type in a y as it did in the event. It will take the F3 value, which is a date, and put it in the cell. If this condition is a no, it looks after the next comma, and here the computer doesn't run in a simple answer, it runs into another if, and that if has its own parentheses. This is why there are two parentheses here. This time we tell the computer to look at D3, see if this field is larger, greater than 0, and if it is, then it will use this date. It will use the date of the end of study. If that's not filled in, then it will use C3. The next one is then just the days, how many days were there between, and it takes the difference between the calculated number here and the cycle 1, day 1 date. PFS is a bit more complex. This is what the spreadsheet will look like in the end in Excel. So we have now columns that identify the event as a binary, yes or no, and we have the time as a numeric with numbers, and this is numbers of days. We have the same thing for PFS here. The next step is to import this into SPSS, and there are two different ways of doing this. But before I go there, let me just tell you about the alternatives to SPSS. SAS is the most traditional software used in the pharmaceutical industry. This is how most of the documentation is created that is communicated with the FDA. Pharmaceutical industry statisticians have this program on their computer, and this is what is used there. The downside is that it is expensive, and it is a bit complex. SPSS is what I'm using here, and that's not because this is the best. This is simply because I came out of academia, and at the time, this was just what everybody used. There are free versions for both of those, but they are quite limited, and they didn't work for me. This is a fairly intuitive, easily usable software, but it costs a bit of money. This one is a younger and more advanced method. The key to this is it is free. You can download it for free, Google it, see it, download R and R Studio on your computer, learn to use it. It is a bit more complex. Anybody who likes programming should go with R, no question, it's free, it works well. If you're more of a clinician and don't like numbers all too much, you may be served better with SPSS. There are others. We're using SPSS, the academic version. And we're back to the point, what do we do after we cleaned the data in Excel? We import them in SPSS. There are various ways to do this. This is my recommended way. Open SPSS first. Click on File. Click on Open. Click on Data. It will ask you which data to import. Fix the file type by clicking on this menu arrow and select Excel. Then select your file and then click Open. There will be questions that SPSS asks you. Just click OK to get over this. In later lessons, you can learn what they mean. Then check the data. Did the import work? This is what it should look like when it worked. Truth be told, for this video, this example, it actually didn't work immediately. I had in Excel an empty line here and above the 1, and that then resulted in losing a line. I had to eliminate it, do the import again, and then it worked. I had the Y and N field as data type general, and by reasons that I don't understand, SPSS didn't take all of the results. I had to change that to text, and then the import works. There is another way of doing it. You can also, within Excel, highlight all the data you want to transfer, copy, go into SPSS and paste there. That will give you the numbers, but it will not give you the titles. Then to fill in the titles by hand. You do that in the variable view. Now we used the first word and we didn't need that. The titles are in there, but SPSS doesn't like blanks in the titles, doesn't like special signs in the titles. So there is the field label there to make up for that. This label I had to type in myself. You can do the analysis from the variable view as well. I showed it before from the data view to now we're in variable view, but the menu above looks the same. Click analysis, click survival, click Kaplan-Meier, enter the time, the event, define the event, click on options, unclick tables, and click plot Kaplan-Meier for it. If you have more complex data and you want to compare different columns, you can do that as well. It gets more complicated, then you need to fill those other things in. But for now, this is how far we want to get. This is our Kaplan-Meier curve. We got it. Now we can click into the curve. We can change it. We can change the colors, the lines, the markers, the axis, the titles. Everything is changeable. I just want to show you one more thing that I found extremely helpful in the first year I did this, and that is the paste button. This click allows you to save your work as code. So if you've never programmed, this is your first program. The way to get there is exactly the same thing. You do all the same steps until you reach the point where you clicked OK and got your curve last time. This time you don't click OK, you click paste. SPSS will create a code file that looks like this. They call it syntax file. And in that syntax file, it will put the order in the way how it could be typed. Now, if somebody knows SPSS code real well, they can actually type this in and not use the menu at all. But that is more complex and takes a lot more videos to explain. What is important here is when you like your first graph, and then you do other graphs or other analyses with your data, you can every time click paste and it will put them all underneath each other. You can save that, and then when you go back to the data, or when the data have changed and you want to repeat all those analyses, you don't need to do all the clicks again. You just click run. And then there's a menu where you click all. And then you will see your new analysis with your new data much, much faster. And this is the end of what we want to show today. Thank you very much for watching it. What did we do? Well, we looked at how to make Kaplan-Meier curves, and the most important thing is you need two columns of data. One is numeric, one is binary. One tells the time of observation. The other one tells if there was or was not an event. Don't start doing curves if any of the fields isn't filled in. Typically, you get the data such that you can't do them because they're dirty, something isn't right. You have to look through them, you have to review them, ask questions back, clean the data, and create the variables that you need. This can be done in various softwares. I showed it in Excel, and the key order here was equal if, parenthesis, type the condition, comma, type what the computer is to do if the condition turns out to be true, comma, type in what the computer is to do if the condition turns out to be false, close parenthesis, you're done. Once you have the data in Excel, you go to SPSS, you import the data, you check them again. They're not always right. Once they look right, you go on analysis, survive, Kaplan-Meier, click survival plot, unclick the tables, click OK. Here is your first Kaplan-Meier curve. Copy it. If you like what you see and you want to repeat the process, later you just go through the same orders again, but instead of clicking OK in the end, you click SPSS and you have your first SPSS code. Save it. Thank you very much for watching. Bye-bye.